Chapter 3, Current Electricity. So initially you have seen or you have heard that this kind of situation taking place where studying after the sunset would be very difficult. Okay, studying in this light, okay, it would found very difficulty because there was no electricity. Traveling distance, okay, traveling small distance would take hours. Going from one place to another, it takes lots of time if you travel in this way. Sending some messages, okay, to your dear one, okay, it's also one kind of a big challenge, okay, to send the messages at that moment because there was no electricity, so you have to send the messages by the post. And another difficulty was about the climate changes. As the climate changes, okay, human get disturbed, okay, and cannot control the climate because from rainy to winter to summer season, and so person feel distracted. But today everything has been changed because of the electricity. Now even if there is no sunset, even during the night time, we can study, we can do the different kind of work with the help of the light which is available in our house, okay, and this is due to the electrical energy. Traveling distance problem has been resolved. Now you can travel from one distance to another, okay, in no minute. Sending the messages becomes very easy because of the emails to just messages can be sent in 1 second. And climate control also taken by the human because of the electricity. Today we can use the air conditioner, okay, during the summer season, so climate can be controlled. So all things has been changed because of the electricity in our life, and which is very important in our day-to-day life. Electric current. First of all, we'll understand what is the word electric current. See, in this lecture you are going to see the basic terms only, okay, and then in next lecture we'll start with the terms which are there in the effect of electric current, okay, and remaining part of the chapter. So what is electric current? So once you heard the word electric current, in our minds this picture comes like getting a shock, okay. Does it mean shock? No, it is not mean shock, okay. Current, what is the meaning of word current? First of all, understand the word current. Current means what? Flow, okay. If the water is flowing, okay, from one place to another, then it is called as a water current. Now if the wind is flowing from one place to another, then it is called as a wind current. And if one news is there that maglev train, bullet train is going to introduce in your country, okay, then it is one news which is follow from one person to another, then it is called as a current news. So basically the current is what? Flow. So if the electric current, if I add the word electric current, so what is the definition of electric current? So it becomes the flow of electrons, because this word comes, electric word comes from electrons, electricity word comes from electrons. So flow of electrons in a conductor. Conductor means any kind of a wire, okay, like copper wire, okay. So that is nothing but a electric current. Electric current, the second definition of electric current can be, electric current is the amount of charge flowing through a particular cross section area in a unit time. This can also be a definition of electric current. Two definitions are there, okay. Electric current is a flow of electrons in a conductor, or electric current flowing in the amount of charge flowing through a particular cross section area in unit time. What is cross section area? Cross section area means thickness of the conductor. Depends on the thickness of the conductor, whether the conductor is thick or thin. According to that, the electric current will flow. So you can write in this way, electric current is equal to, the definition can be made in this way, amount of charge divided by unit of time. So this is how the formula can be made of electric current, that is electric current is equal to amount of charge upon unit time, okay, and this is only the definition of electric current. Next, what makes the charge flow? See, in this definition of electric current we have heard that the flow of charge, okay. So but what does the basically make the charge flow? who tells the charge to flow. So let us understand how does the charge flow during the electricity with the help of a small activity. Now we have taken a two beaker, you can see. Let us consider two beakers. One beaker, one tank is A and another beaker is B. Now we have connected both this beaker with the help of a one beaker is at the high level and second beaker is at the low level, and they are connected with the stopcock. This is an stopcock, okay, or the tap of your tap. There is a cock is there which if you release it, okay, the water will comes. You will fill the water in the beaker A. This is a stopcock. Yeah, this is a regulator, you can say. Okay, when you open the stopcock, what will happen initially? Initially, there is a water in both the beaker, in A also as well as in the B also. Okay, when the stopcock is closed, water does not flow. Now the water is not flowing basically. Right now, the water is not flowing. But when the stopcock is open, okay, what will happen? The water will start flowing. See, the water will flow from beaker A to B, not from B to A. And the water will rise in the beaker B. So water always flow from high level to low level. From this activity, what we came to know that water will flow from high level to low level. Okay. One more, another activity. Suppose to take two objects. Okay. One object A and second object B. In first object A has a temperature of 90 degrees Celsius and second object B has a temperature 20 degrees Celsius. If both the objects combine together, this is high temperature, this is low temperature, and when they combine together, what will happen? The temperature will transfer. That means heat will transfer. Heat flow from A to B, that is from high temperature to low temperature, not vice versa. Okay, from 90 degree to 20 degrees Celsius, heat will flow. So from here we will introduce one concept, one term, that is cell. Now cell, this is not a biological term. Okay, this is not a basic unit of your living organism. This is a cell which is used in the remote control, all that is called as a cell. Okay, so that cell we are going to understand in this electricity world. Now here the symbol of the cell is this. Okay, this is simple way, you don't have to draw that particular cell. Okay, the symbol of the cell represent in this way, in a simple straight line, and in that there is two lines, is there, one bigger line and one smaller line. Bigger line is called as a plus and smaller line is called as a minus. Okay, and this is how the actual cell look like. Even if you see your cell which is used in a remote controls or toy car, there is a written on that cell, one side is plus and one side is minus. So the plus side is called as a positive terminal and the minus side is called as a negative terminal. What is terminal? Terminal is a place, okay, where all the charges are reserved, where all the charges are stored. Okay, so positive terminal and the negative terminal. Okay, it is a starting or ending point basically. Now positive terminal has plus 1 charge and negative terminal has minus 1 charge. So can you say which number is greater, plus 1 or minus 1? Answer is plus 1. So therefore positive terminal is called as a plus 1 is a bigger number and minus 1 is a smaller number. So therefore positive terminal is called as a higher electric potential and negative terminal is called as a lower electric potential. Remember this. Positive terminal is called as a higher electric potential and negative terminal is called as a lower electric potential. So potential means what? Potential means level. Okay, potential means level. So when difference between the higher potential and lower potential, the difference between higher potential and lower potential, इसके डिफरेंस को हम क्या बोलते हैं? इसके डिफरेंस को हम बोलते हैं पोटेंशियल डिफरेंस. Okay, so now you have heard this word first time. Okay, you have heard this word before also, if you remember in 9th standard. If not, then today this word is introduced for you, that is potential difference. Very important term. Okay, this term is very important throughout this chapter and later also when you take a science in 11th standard. Okay, in this electricity world, this term will come again and again. Without potential difference, there is no electricity. This all relation that you are going to study further in this chapter. So remember, the difference between the higher potential and lower potential is nothing but a potential difference. So the function of the cell is to create the potential difference. What is the basic function of this cell? To create the potential difference. If there is a potential difference, then there will be a electricity. Okay. Next, now let us know what is free electron. See, in the electricity, when the electricity is produced, the free electron play a very important part. Okay, so now how does this free electron is obtained? So to understand that, we'll take one atom. Okay, there is a nucleus, inside that there is a protons and neutrons, which we know, and they are surrounded by the electrons on this orbit. This structure you have seen many times from 7th standard, 8th standard onwards. Okay, this, you know, this is the center part of the atom, that is nucleus. Nucleus contain the protons and neutrons, and this blue color is nothing but electrons, and this are on their particular orbit. They are called as shell, you know, K shell, L, M, N. These are the shells in which the electrons are divided. Now the electron always keeps on rotating around the nucleus because of the positive and negative charges. So the charges between the nucleus and the electrons are called as there is attraction always between the electrons and the nucleus. Okay, and this attraction take place because of one force, and that force is electrostatic force of attraction. In non-metal, what happened? Basically, the number of electrons in the outermost orbit is more. We know, we have studied about metal, we have studied about non-metal. Okay, so in non-metal, what happened? The number of electron in outermost orbit is always more. Okay, that is how much electrons are there, that is 5, 6, 7, this much electrons are always available. So the removal of this electron is not possible. But in case of, because they are strongly bounded, but in the case of metal, if you see, the number of electrons in outermost orbit is less. It can be 1, 2, 3 electrons. Okay, so can you remove this electron? Yes, because these electrons are lightly bounded, loosely bounded. So one of this electron will come out. Okay, and the electron which came out, okay, which escapes, is called as a free electron, and this kind of electron only is useful for production of electricity, and this kind of free electron flow in the conductor, I mean to say wire, in a wire.